Welcome to Real Civil YouTube channel. In this video, I am going to discuss related to the ultimate load combinations and how the different load combinations are formed. This will be a advanced load combination video because we are going to see the clauses from IS 456 as well as from IS 1893 2016, that is from earthquake code also. So let's begin with ultimate load combinations. So here in IS 456 table 18, it has provided us the different load combinations and partial safety factor values, and this is the limit state of collapse. So today we are going to see these combinations. In our previous video we have covered limit state of serviceability. You can click on I button or you can see the description box. If you want to watch that video, the link is there. So this table I have simplified here. Yes. So basic ultimate load combinations as per IS 456 code. So there are basically 7 load cases. The first one is 1.5 times dead load plus live load. Second case 1.5 dead load plus earthquake. Third case 1.5 dead load plus wind load. Fourth case 1.2 times dead load plus live load plus earthquake. Fifth 1.2 times dead load plus live load plus wind load. Sixth case 0.9 dead load plus 1.5 earthquake. And seventh case 0.9 dead load plus 1.5 wind load. So basically this first case is 1.5 dead load plus live load, and then second case 1.5 dead load plus earthquake. Then we substitute this earthquake case with wind load, so that becomes our third case. In fourth case, dead load plus live load plus earthquake, and the factor is 1.2. Now we have considered 3 load cases, and similarly this earthquake case will be replaced by wind load. Remaining things are same, and that will become case number 5. Case number 6 is 0.9 dead load plus 1.5 earthquake, and if we replace this earthquake case with wind load, then we can create our seventh case, that is 0.9 dead load plus 1.5 wind load. In last lecture I have discussed about the basic load cases. If you seen these ultimate load combinations, there is a dead load case, live load case, earthquake case, and wind load case. So there are basically 4 load cases are there: dead load, live load, earthquake load, and wind load. So dead load means it includes the self-weight of the structure as well as the superimposed dead load such as floor loads, wall loads, lift load, etc. Then live load consists of, we calculate this based on the occupancy as per IS 875 part 2. Then very important, earthquake load. In earthquake load, we perform the seismic analysis either by equivalent static method or a response spectrum method or time history method. Suppose we perform equivalent static method, or sometimes we need to perform all three. Sometimes we need to perform static, equivalent static, and response spectrum, and rarely equivalent static only. It is now mostly we perform equivalent static plus response spectrum, but in many cases we need to perform the time history also. So if we perform equivalent static, then there will be four cases: EQX plus, EQX minus, EQY plus, EQY minus. In response spectrum, there will be three cases: response spectrum X, response spectrum Y, and response spectrum Z. There is no negative case because it includes the negative direction in analysis. I am not going that detail, but there will be three cases. In time history, again there will be time history X, time history Y, time history Z. So again there will be three cases. And in wind load X positive, X negative, wind load Y positive, Y negative. So there are four cases. And let's assume that we have performed static wind load cases. There are dynamic also, but if there is dynamic, you can include that dynamic wind load cases also. Okay. So these are our basic load cases, and these are our sub cases. Here you can see all these are sub cases. We have to include all these sub cases while forming our ultimate load combination. Okay, let's begin. So just look at this case: 1.5 dead load plus live load, and second case 1.5 dead load plus earthquake. Okay. So our first case was 1.5 dead load plus live load. It will be as it is, as there are no any sub cases. Second case was 1.5 dead load plus earthquake, right? But in earthquake, we know that if we perform equivalent static method, then there will be four cases. In response spectrum, there will be three cases. And in time history, there will be three cases. So in total, there will be 10 load cases or load combinations. So what we need to do, 1.5 in bracket dead load, this part will be constant. Okay. And we have to first put earthquake X positive, then earthquake X negative, earthquake Y positive, earthquake Y negative, response spectrum X, response spectrum Y, response spectrum Z, time history X, time history Y, and time history Z. 1.5 and dead load will remain constant. We have to consider the sub cases under earthquake. Then in our third case, 1.5 dead load plus wind load. Okay, so we know that again in wind load there will be four cases: wind load X positive, negative, Y positive, negative. So there will be four cases: 1.5 dead load plus wind load X positive, 1.5 dead load plus wind load X negative, 1.5 dead load plus wind load Y positive, 1.5 dead load plus wind load Y negative. Similarly, in fourth case, it is 1.2 dead load plus live load plus earthquake. Now you know under this earthquake there are sub cases. Okay, 10 sub cases are there. So you have to put one by one. Similarly, 1.2 dead load, live load, wind load. In wind load there are four sub cases. Similarly, 0.9 dead load plus 1.5 earthquake. So we have to replace again this earthquake with 10 sub cases. You can take screenshot also. Then 0.9 dead load plus 1.5 wind load. And we know that in wind load there are four sub cases. So this is how we have created 43 load combinations. In your case, depends how many type of earthquake analysis you are performing. The final load combination count will depend on that. So this is the first part. Now let's go to IS 1893 2016. This code IS 1893 part 1 2016, and you have to come on page number 7. Very important. clause is there. 6.3.2.1. When lateral load resisting elements are oriented along two mutually orthogonal horizontal directions, structures shall be designed for effect due to full design earthquake load in one horizontal direction at a time and not in both directions simultaneously. That means whatever load resisting elements are there, for example, column is there, shear walls are there, they are oriented along two mutually orthogonal horizontal directions. That means suppose this is y and this is x, and our columns and beams are oriented in this way. I'm just giving an example. This is mutually orthogonal case. That means columns, shear walls are orthogonal to x and y axis. They are not making any angle. For example, suppose there is no any column like this or shear wall which is oriented at some angle. Just a minute. I'll switch on the button charging. Okay. If this is the case, then you have to follow these load combinations. Okay. That means we have considered only one direction earthquake in load case, not two direction or third direction of earthquake. So these load combinations are okay for this particular case. That means your load resisting elements are oriented along two mutually orthogonal horizontal directions. Okay. Let's see the next case. 6.3.2.2. When lateral load resisting elements are not oriented along mutually orthogonal horizontal directions as per 7.1 and table 5e, structures shall be designed for, very important, simultaneous effect due to full design earthquake load in one horizontal direction plus 30% of design earthquake load along the other horizontal direction. Thus, structure should be designed for the following set of combinations. That means, for example, if you are considering earthquake x direction full, that is 100% plus or minus ELX, then you have to consider 30% of earthquake in y direction. So this will be the case plus or minus ELX plus or minus 0.3 ELY or plus or minus 0.3 ELX plus or minus 0.3 ELY. That means suppose this is your plan and these are your directions, and suppose the columns and shear walls are oriented with some angle theta, then you have to consider this. So they have given here, they have explained here how to incorporate this, or I can give you one example. Yes. So remaining cases will be there. We know that our second case was, just look at here in the green color, 1.5 dead load plus earthquake in x direction we have considered, right? Let me show you. In orthogonal case, this was our first case, 1.5 dead load plus earthquake x positive. Now, if our lateral load resisting elements are not oriented mutually perpendicular, means they are making some angle, then instead of earthquake x positive, you have to consider earthquake x positive plus 0.3 earthquake y positive, means 30% from other direction. Then next case will be dead load plus earthquake x positive minus 0.3 earthquake y positive, because if you see here in the code, here you can see plus or minus earthquake in x direction plus or minus 0.3 earthquake in y direction. That means we have to consider both the signs. So here we have considered positive earthquake x positive 100% and plus or minus 0.3 earthquake y positive. Then here you can see the fourth case, minus EQX plus 0.3 EQY plus. So we are now considering the negative case of EQX and positive of 0.3 EQY. Similarly, 1.5 dead load minus EQX positive minus 0.3 EQY positive. So you can see this is how we have created the load cases. And the code says if you have analyzed considering the all three directions, then same way plus or minus earthquake in x direction plus or minus 0.3 earthquake in y direction plus or minus 0.3 earthquake in z direction. Similarly, full earthquake in y direction 0.3 z, 0.3 x, and every time there is a plus or minus. Similarly, full earthquake in z direction 0.3 in x, 0.3 in y, again plus or minus. To explain this, I have created one case here. You can read 18 number case. As there is vertical analysis will be there in response spectrum and time history. So you can study this case 1.5 dead load plus response spectrum x plus 0.3 response spectrum y plus 0.3 response spectrum z. Okay, we have created with all positive signs. Now in next case, in 1819 case, we have changed this sign minus 0.3. In 20th case, we have changed the sign here minus 0.3 RSY. In 21 case, we have changed to both negative, and we have kept the plus response spectrum x case constant. Okay, here also. And now we have started to create minus response spectrum x. There will be 4 cases minus response spectrum x, and then you have to change the sign similarly. Means my intention is to tell you that you have to consider both plus and minus, plus and minus, plus and minus. Now the last case is if your columns shear walls, the lateral load resisting elements are oriented at an 45-degree angle spatially, then you have to consider this case of load combination, which is SRSS. For example, EL is equal to square root of earthquake in X direction square plus earthquake in Y direction square plus earthquake in Z direction. So this is another case when your structure is lateral load resisting systems are oriented at an angle of 45-degree. You can use this case. So I will show you one example. So instead of 1.5 dead load plus earthquake, so here it becomes 1.5 dead load plus, you have to consider the SRSS case, that is equivalent static SRSS. So what is equivalent static SRSS? Equivalent static SRSS will be equal to square root of EQX square plus EQY square. Similarly, 1.5 dead load plus response spectrum SRSS, that is response spectrum in X direction square plus response spectrum in Y direction square plus response spectrum in Z direction square. Similarly, EQTH time history SRSS, then time history X direction square plus time history Y direction square plus time history Z direction square. So this is bit advanced stuff, but make sure you are aware of all these things. In the next video, I will tell you how to import this load combination in ETABS software and how to form these combinations in ETABS software quickly. I hope this video will be useful for you. It was little advanced stuff, but I hope you will get if you watch it again and again. Please like, share, subscribe the channel. Thank you so much.